Hello, everyone. I hope you are doing well. My name is Hieu. I'm from the Digital and App Innovation Global Black Belt team from Microsoft. And essentially today, I'd like to walk you through something that I've built for my customer. And it is a solution that will help you to implement cost rate limiting on Azure API Management. So let's get into it. First, I'd like to open up my Azure portal just to show you my API management service. So as you might recall, I want to set level set that I previously actually wrote a article on how would you actually implement a event hub logging for Azure OpenAI streaming APIs. So essentially, this is one of the approach where I actually use an Azure Functions in order to act as a proxy, and all of the API management chat completions requests will actually go to this proxy, and then this proxy will actually communicate to Azure OpenAI. So by having Azure Functions as a proxy, then I can actually support both the non-stream and streaming APIs and be able to measure the token usage as well as the input cost, the input prompt and output prompt, and actually propagate all of these telemetries and latencies into Event Hub. And then from Event Hub, I have another functions that actually record or propagate some of these data into Cosmos DB for visualizations as well as analysis on the prompts as well as the latencies and then the token usage for each of them, right? So this actually support both streaming and non-streaming APIs. So you can actually have a look at the article. So actually, as a extension of this article, I have actually provided a further expansion on how would you actually implement cost rate limiting. So in short, if you want to actually organize an hackathon and then you want to give it, let's say, $10 for each team, for example, to go ahead and explore with LLM. But you want to kind of rate limit them so that, as long as they are calling the model chat completion, they can use as they please until the $10, then just help me to rate limit it, right? So one the approach that I actually built, let me first show you on how it actually works, and then I'll walk back onto the implementations, right? So here we have like Contoso, like let's imagine that there is a group called or a company named Contoso. I give them $20, or there is like a starter product that is $10 or $5. Let's go with the simple one first. So with the $5 product, so let's actually first look into first of all the policies, right? The policy that I have is basically a fragment that will help you define, first of all, the counter key. So I try to actually implement this quite similar to the popular rate limit by key feature of Azure API Management. So essentially, you can actually put in like a product ID or subscription ID or user ID or any kind of ID that you'd like. And then all of the quota usage will be counted against that counter key, right? And then, of course, that you will be able to set the quota, which is in USD. And here I set like $5. And then I can set also the start date and the explicit end date. So both of these dates are optional. So if the current date fall within the period, either bounded by the start date or the end date, then I will actually start counting. Otherwise, if it fall outside of that, then I'll just return a 429 rate limiting. And then there is a renewal period when that is defined in seconds. So this is defined as a 1 day. So the accumulation will actually refresh every 1 day starting from the start date. And if you actually go into the next day, then your $5 will be restored. Again, like this will be optional, but if you don't define it, then I don't reset that cost ever. So if you run out, then you just be fully utilizing your $5, right? All right, so I have this product, and then I actually associate it with my chat completions API. And then I actually give this products, access into the developers group and admin group, right? This is out-of-the-box API management features. So here, if I go into my developer portal as a developer, then I'll just go ahead and have a look at some of these APIs. So I'm already logged into my profile. That is, my name. And then I'll go ahead and explore some of the product that is only visible to me and not anyone who is not logged in. So I'll be able to see, for example, the starter 5. I'll click into that. That's the $5, and then $5 quota product. And then I'll register, okay, $5 quota subscription, right? And then I subscribe to it. All right. So now you see there is a primary key and secondary key already generated. So I'll just simply use this, and then I'll actually use this as a Azure API Management subscription key. And then I'll just provide it into my HTTP client that you can see here. So this is calling against my API management, and then I'll just provide the API management key here, right? So let me go ahead and just click on send. All right. So take a bit of time, but you see, I think I asked like, you are a helpful assistant. Tell me about Singapore in one sentence. And then it generates for me, the content, obviously, and then, some of these content filter and then the usage, right? So what my API will put on top is essentially, the current cost. So basically, the cost of this API call, multiplied by the input token and output token. So all of these is enough for me to so all of these usage token along with the models here is enough for me to calculate how much is that LLM request actually cost, right? And I actually also input in a few headers that will give me the quota, that is the $5, and then the accumulated cost here, right? So what does it, how is this actually implemented is I actually use Cosmos DB, and I actually use a stored procedure within the Cosmos DB. So the one of the key reason why I actually use a stored procedure is because I want to ensure all of the actions for persisting and accumulating the cost is actually atomic. So the moment I get the existing cost, and the moment I add to it, and the moment I save to it, I want it to be a single transactions, atomic, so that I avoid any sort of race condition when I have like, thousands or millions of transactions at the same time. I don't want it to overlap each other and then storing the wrong values, right? So yes, this is one of the key thing where Cosmos DB is actually perfect for this because it provides like not only the stored procedure but also a capability to allow you to partially update and to partially incrementally update as well a document. So if you were to look into my Cosmos DB, let me remember which one it is. Okay, this one. So this is the data explorer, and then I have the user budgets, right? So the user budget now will store the ID as the counter key. And if you were to go to this starter 5, then you actually see that, okay, I have the ID that is starter 5 is the same as the counter key. And then this is the accumulated cost, right? There is all the start date, renew period, renew start for each window. And once the renewal window passes, then I will update this renewal start. So this is all done within the stored procedure itself. There's just a little bit of logic on checking the start date, end date, and renewal windows. But yeah, you're gonna see there is a quota right here, right? And if I'm gonna call it the second time, um, if I'm gonna code this the second time, you see this value is actually updated. And then if I go outside and then go back in, then you see this value is now updated, right? And then I can, so the key difference here is that I do support streaming, right? So if I were to do streaming right here and remember this value, right, 915, if I were to save it, so the interesting about the streaming is that the accumulated cost here, so all of the response header, I need to hydrate them at the beginning of the call. And then the chunks will come, right? The server sent event chunks will come. And then after all of them arrive, I cannot go back and then actually adjust or add more the response header. So at least that's something that so far I'm not able to do yet, unless probably I move to a newer level of HTTP protocol. But right now, then I'll just first of all I check whether the current accumulated cost is already past $5. And then I will actually hydrate what is the current accumulated cost before the call, and then I hydrate the quota as well. So a lot of these is already visible for the caller, and can actually expect like how much is left, right? So you see this is calling well, and then if I were to, let's say, adjust this value, right? Let me intentionally update it so that it's actually exceeded. So if I were to do this, then I'll send the same request again. Remember, I'm currently using streaming, right? The streaming options and include usage. Actually can prove that as well, that in the usage here, not only I have the completion tokens, the prompts, the total tokens, but I also inject in the current cost, right? And then the cost tracking object that I actually use to update against. So it's calling against starter 5. So I know like very well on what's going on with cost tracking here to do like debugs, as well as keeping track of the renewal, etc. And this is not something that the user can override. I can only define this in API management. So if I were to call this again and remember that the accumulated cost now is already exceeded, so it sees that, oh, it's already exceeded because the accumulated cost is currently $5, and then $5 and 000 and 915, and then we have the quota that is $5. So it's already larger than that, and then the counter key is starter 5, and then the rate limit quota exceeded, right? So this is awesome. So right now, the moment I want to kind of implement sort of a new policy, let me see. If I were to go back to API management here, so from API management, and then as far as using this solution, then it's pretty much native to API management. You don't have to actually create, additional UI to set the budget or to delete the budget or to add user to that budget, but it's all native to the built-in access control and the product concept of API management, right? So so then you see like I can create like further products, and the policies are rather compact right here. So I have like a starter 10 product, So the main thing that is interesting here is that I actually also put a support for a custom input cost and output cost per token. So this is rather important because, as you know, like, we are working with many customers, and then each of the customers actually, depending on their commitment tier, then they will have a different discount level. So the pricing could be different, depending on the customer. So if you were to actually have a special pricing, or if we have a price change on the model itself that it certainly become cheaper, then you can actually provide your own cost here. Then instead of so I will actually use this cost to calculate the cost, the actual cost of that request for you. But if you don't provide this, then currently the implementation relies on this light LLM model prices and context window JSON. So this JSON is actually a great knowledge base for all the pricing of all of the models that exist on the internet, right? So you can actually find DeepSeek as well, like Azure AI DeepSeek R1, and then you can actually find GPT 4.0, and then you can find like O1, you can find O3, and kudos to Light LLM that they update super regularly. So if you don't provide a custom input cost and output cost, then I'll use this JSON. But if you do, then I'll use yours definitions to calculate the cost, right? So this has been a bit of work to actually implement, because, like, as you imagine, it's a little bit of policies in API management. So the policies here, we have like this magic fragment, but it's also not a big implementation. So if I go into this rate limit config, then you will be able to see that this rate limit config is just setting the bodies of that variables into the post JSON body. So so behind the scene, then you will see that we have this messages and then stream. So what this fragment does is that it will create this rate limit config object, and then it will inject it in here, right? And then it will inject this in here. So, and then it will put all of the counter key of the product, etc. So in Azure Functions, where I process this LLM request, then that rate limit is actually an optional. So if you define the rate limit, the cost rate limit, then I'll look into that and query Cosmos to find out if it's exceeded, and then track the cost against that. But if you don't provide this, then it's just your regular LLM. You can use any existing token usage or token rate limit per minute. Just like how you would do it, with the built-in policy from Azure API Management. Okay, so yeah, and I think with this, then we are able to not only provide a Event Hub integrations with streaming APIs and non-streaming APIs, but now we are able to also provide like cost rate limiting feature on top of the API management functionality, right? And the cost rate limiting is essentially, we have a rather straightforward, Cosmos client that actually check whether the quota is exceeded and returns whether it's exceeded or not. and the track cost with the stored procedure. So essentially, all of the rate limiting config, then we'll actually propagate it to the stored procedure, right? So all of my code is currently open source and available as you see on the URL here. And yeah, I hope you like the implementation, and I welcome any contributions that you would like to add to. But with this, imagine that you can now give like $100, $1,000 to a certain department and that you have internally within your company. And then you can actually use that to kind of control the cost of everyone who is leveraging Gen AI functionality in your organizations. So I hope you like it. Thank you so much for tuning in.